So as with any type of reflecting surface, whether that's a plane mirror or a curved mirror, we always have some potential for defects. And the defects that we get with mirrors are called aberrations. There's many different kinds. A spherical aberration is caused when the mirror is not a perfect sphere. It might be a little misshapen, there might be a bump someplace. A chromatic aberration is an aberration with the color. Because different colors of light have slightly different wavelengths, that gives the potential for a slightly different focal point for each wavelength. That may not make a lot of sense right now, but I have a diagram on the next page that should help with that. Astigmatism. Many of you with glasses may have astigmatism. I do myself. What it is, it's another misshaping of the eye, or of the lens, or of the mirror. We hear about it in terms of eyes all the time, but we can actually have it with lenses. The last one, not commonly associated with optics, but a coma is another imperfection. It's slightly different than a spherical aberration or an astigmatism, because what a coma does, it doesn't actually blur the image, it makes it appear that there's like a tail coming out of the image, kind of like when you see a comet go by. We're going to focus on the spherical aberration because it's the one that we can control and it's the one that is the most easy to understand. So on the left, we have a perfectly spherical mirror. As the light rays, which you can see in white, go towards the mirror, they get reflected back to a common point, which is about here. Now, as you can see, the light doesn't focus exactly on that point. It bleeds up, it bleeds down, and it bleeds to the left. That's why you would get a blurry image if you used a perfectly spherical mirror. There's no way to correct that. We would just have to accept the blurriness that's there. A way that it can be corrected is with what's called a parabolic mirror. Now, a parabolic mirror is a slightly different shape. It is a parabola, which in Foundations of Math 20 and Pre-Calculus 20 we will talk about at length. But as you can see at that focal point, all the light comes straight into the point right here. There's no bleeding up, down, or left. The light all comes in and we lose that spherical aberration. We can't ever completely remove it. There will always be some imperfections, but using a parabolic mirror is the easiest way to minimize those.